Good morning, my fellow scientists. It is Monday, October 9th, 2017, and I want to talk to you about the iron battery. For all of you new viewers, I have been working this last year on developing an all-iron cell that has an iron anode that dissolves and a iron salt cathode that is reduced from iron 3 to iron 2. That means that all of the chemistry is iron, so it can't self-contaminate, unlike other batteries where if the anode chemistry and the cathode chemistry mix, it kind of ruins everything. So that means that there's no additional salts to self-contaminate, and that there's no additional toxic components that might be forbidden for use in your home or that might cause contamination to the environment. So I like iron chemistry for all those reasons, and I've been trying to make the iron cell work efficiently. The downside to all of this is that it's going to be very heavy, and that iron 3 EDTA is somewhat corrosive to most materials. So, for instance, a copper based current collector to connect everything up is a bad idea because iron 3 will etch copper. Iron 3 will also etch aluminum, it turns out. And so I went to gold, and that's been the saga for the last week or so. I have got some gold foil, some gold leaf, or what I thought was gold leaf, and I attached that to a piece of plastic. Originally it looked a lot like this. You can see gold on plastic. And over the course of the weekend, that gold foil is no more. All that glitters is not, as they say. This, I believe, is actually a brass foil, despite being marketed as pure gold. I don't know if you can see there, but that's kind of a bluish tint to the to what's left there. Yeah, that was yellow metal on Friday, and it is now blue-green corroded gunk on Monday. Blue-green corroded gunk says copper to me, and the fact that it's a yellow metal says brass. So I could be wrong. It could be something really weird without going down to the X-ray scattering or the EDS. I'm not going to be able to know for sure. But for now, yeah, the gold foil is not an option. What is probably brass foil is going to corrode, which if I'd known it was brass, I wouldn't even have tried it because I would have assumed it was going to corrode. So we'll try silver foil next. I do hope that the silver foil isn't actually aluminum or some ridiculous thing. It says 0.999 silver, so one can hope that it's actual silver. And we'll find out if that's going to work or not. In the meantime, the battery did cycle a large number of times, so I will show that data here. You can see that the charging goes on for a lot longer than the discharging. That probably indicates that we're losing a fair amount of current during charging. It's just not very efficient, but it did cycle stably for hours and hours. That's something like 10 cycles up and down. So that's a good thing. In general, we're making progress toward an all-iron battery. Hopefully we can get the chemistry of the current collector sorted out and see how much difference that makes to the efficiency of charging, because I think it'll make a significant difference. So if you like that kind of thing, tune in Monday through Friday. We update on batteries and new battery technology and the batteries we're developing right here in the Allen Lab.